All right, let's jump right in. Today, we're going to put on our detective hats and dive headfirst into the world of logical investigation. We're talking about how logicians and computer scientists crack their absolute toughest cases. So let's kick off our investigation with the one question every logic detective has to face. So let me just ask you this, right off the bat. How do you actually prove that something is always, universally, 100% true? No exceptions. It's a way bigger challenge than you might think, and honestly, it's the central mystery we're going to unravel today. Okay, let's use a super simple example to see what I mean. Imagine the statement, all birds can fly. To prove that's true, you'd have to check every single bird that has ever lived or ever will live. I mean, that's literally impossible, right? But to prove it's false, all you need is one exception. You find one penguin, one ostrich. Boom, case closed. This perfectly shows the two sides of our investigation. And that brings us to our official toolkit. On one side, we have the search for a proof. That's the evidence that shows a statement is true across the board. And on the other side, we have the construction of a countermodel. That's our one penguin, the single exception that proves the statement is actually false. You know, every good investigation starts with a case file. And in our world, that file has just one thing in it, a single, mysterious, logical statement. I want you to think of every logical formula like it's a suspect in an interrogation room. It's sitting there claiming, I am universally true. And our job, as the detectives, is to really scrutinize that claim. Is its story completely airtight, or is there a tiny little hole in its alibi that we can expose? So, the investigation begins. The first thing we do is take the statement's claim seriously. We start by hunting for any and all evidence that could prove it's telling the truth. This is what we call the search for proof. Now, a proof search isn't just some random look for clues. Oh no. It's a methodical, step-by-step process. You're trying to connect every single piece of evidence, from the first clues all the way to the final conclusion, to build a case that is absolutely, completely airtight. One of the coolest techniques they use is called directional deduction, and it's pretty much exactly what a real detective does. First, you start with the clues you're given, the premises. Then, you break them down. You dig deep to find the most fundamental facts, the ultimate grounds. And then, from those core facts, you build your case back up to create a rock-solid conclusion. And just like a real detective knows you can't use the same technique for a bank robbery and a missing person case, a logic detective has a whole bag of tools for different kinds of logic. You know, whether the case is dealing with the straightforward rules of classical logic or the tricky possibilities of modal logic, each one needs its own special set of forensic techniques to get to the truth. But what happens when you hit a dead end? You've followed every lead, you've analyzed every clue, but the chain of evidence, it just isn't coming together. The trail goes cold. So what does a good detective do then? Well, you start to consider the alternative. You flip the script. You start thinking, maybe, just maybe, this suspect isn't guilty after all. Maybe they have an alibi. And this is the exact moment we pivot from searching for proof to hunting for a countermodel. This quote just nails that shift in mindset. It's a total 180 in the investigation. As soon as the prosecution's case starts looking weak, it's time to start looking for the one piece of evidence that can clear the suspect's name. And that perfect alibi, that's the countermodel. We're not trying to prove the statement is always true anymore. Nope. Now, we're on the hunt for just one specific, concrete scenario where it is flat out false. If you can find that, the entire case for its universal truth just completely collapses. So you gotta remember, a proof has to be a perfect, unbreakable chain. But a countermodel? That's the sledgehammer. It's the one single, flawed link that you find and use to shatter that entire chain into a million pieces. It's incredibly powerful stuff. Okay, so every investigation has to end with a verdict. So how do these two totally opposite strategies, the prosecution and the defense, lead us to a final judgment? It all comes down to this duality. On one side, you have the prosecution doing everything they can to build an airtight case to prove the statement is always true. And on the other side, you've got the defense, and all they need to do is find one undeniable alibi, one single case where it's false. The outcome is binary. You either find a proof or you find a countermodel. That's it. And here's the really mind-blowing part. For certain types of logical systems, this whole process is guaranteed to give you an answer. These systems are called complete, which basically means the detective will always close the case. No matter what statement you throw at them, they will eventually find either a foolproof or a definitive countermodel. There are no cold cases, ever. Now, this all might sound pretty neat and tidy, right? But in the real world, well, this is one of the most difficult jobs in all of logic and computer science. Let's take a quick look at why. The biggest reason? It's the sheer number of possibilities. When a detective is searching for a proof, they're not just checking one or two logical paths. They're facing what's called a combinatorial explosion, a number of possible paths so vast, it's almost impossible for us to even comprehend. So let's just recap the biggest challenges. First, that search space we just mentioned is just astronomically huge. Second, even when we get computers to help us find proofs, they often spit out an answer that's basically unreadable to a human. It's like getting a brilliant deduction, but it's written in an alien language. And finally, there's this deep, theoretical gap. Proofs and countermodels are often seen as coming from completely different worlds, which makes it really hard to switch from looking for one to looking for the other. And this really brings us back to the human element of it all. The whole point isn't just to get a yes or no answer from a machine. It's about understanding why. It's about translating this incredibly complex web of logic into something that a person can actually look at, understand, and learn from. And so we're left with this one last lingering question. If our best detective, with all our best tools, searches and just cannot find a proof, what does that actually mean? Does it mean the suspect is really innocent? Or does it just mean that the one crucial piece of evidence is still out there, just incredibly well hidden? It's a question that really pushes the limits of what we can ever truly know for certain.